Hello, today we want to take a look at the graph that you see here. This graph is actually of 6 different spacecraft flying through space, and some are faster than others. I think they're actually slow for spacecraft, but we're just going to go with it. You guys know that whenever we get velocities of something, we need to take the slope of the line, but you also know that when we record a velocity or a speed, it's always going to be over 1 second or 1 minute or 1 hour. So we might say 70 miles for every 1 hour, something like that. All right. So it's in the denominator is one of whatever is on the x-axis. But if you look at this x-axis, we don't have one. This doesn't count up to one. It only counts up to 0.5. It counts 0.05, 0.1, 0.15, 0.2. Okay, and so how are we supposed to write this as a number over one? How are we supposed to tell how far it's going every 1 hour, as time is given in hours here? All right, and the thing is, what you already know is that you can take the slope of at any spot on this straight line, and it will give you the same number. The slope is the same everywhere. The velocity is the same everywhere. All right. So we're not going to take the slope for a whole second. We're going to take the slope for whatever is convenient to us. And then we're going to change it so that it's over 1. All right, so let's take a look at this. It looks like it starts at 0 here, this gold line here. Starts at 0 and it continues on and continues on and continues on. But it's going to be hard to read because it doesn't go exactly through the corners of the lines. All right, in fact, there's only one corner that it goes through pretty close, which would be this one right over here. All right, at least if it kept going, it would go through that corner. So that's the one I'm going to actually try to find try to use here. All right, and so I know that looking at the x-axis, if I measure 1/2 of an hour, 0.5 of an hour, I know that that is, I have to go up to this line, and then it went 300 miles in that half hour. That's a really slow spacecraft. All right. But it went 300 miles in that half of an hour. All right. So what can I do with that? I'm going to write that down on my whiteboard here. I'm going to write 300 miles for a half hour. Oops, disappeared my whiteboard. I'm going to write 300 miles. Whoa, it's going away. I'm going to try again to write 300 miles for 1/2 hour, 0.5 hour. How do I make that into a number over 1? Well, you guys know proportions. You know that you could write 1 hour here and then you could solve this proportion. Okay. Well, how do you solve this proportion to find the miles or the distance or the displacement here? I'm going to call that a displacement. So I'm going to call it delta x, which is our symbol for displacement. How do I solve this to find out what delta x is? Well, in math class, you would just multiply both sides by 1 hour. Okay. And then you would solve. So you would take 1 hour times 300 miles divided by 0.5 hours. All right. And when you do that, you solve that and you end up with x, delta x, the change in position, in 600 miles. Okay. So we know that our answer is 600 miles for every 1 hour. Okay. I kind of made a mess of that, but 600 miles for 1 hour is our answer. Okay. To do that, you always do it the same way. It doesn't matter what number you have in your denominator. As long as you make it equal to 1 hour, you can solve for what you want right here. Okay. Now, this one was also an easy problem where you could just think about it a little bit. And you know that 1 hour is twice as big as 0.5 hours. So 600 miles must be twice as big as 300 miles. But otherwise, multiply both sides by your hours and you will get your answer. Or, since 1 doesn't matter when you multiply it, just divide the top by the bottom.